So Christopher is going to talk about his favorite subject, I think, which is the theory of semigroups, and the historical perspective about the interaction between the US and European mathematics during that 20th century. Thank you very much.
Thank you. So yeah, I should start by thanking Simon for the invitation, and also maybe I should comment my ability to speak French is extremely limited, so I'm very happy that you're prepared to indulge my English, and I can't read the Thank you. Good. Thanks. Okay, so this is a subject that I've been quite happy to come back to. As Simon said, the development of the theory of semigroups is something I've looked into. And in preparing this talk, I've had to go back to some old material, but I've had the opportunity also to unite that with some work I've been doing recently. And a very nice thing happened when I was sort of uniting these things, that I had a sudden revelation and made a connection that I had never seen before, which meant I had to sort of replan the talk halfway through, but that's okay. So there's some nice new things to include here. And so, of course, the theme that I was given was interactions between European and American mathematics during the 20th century. And I think the development of the theory of semigroups is a good example of this. So what I plan to do here is just to give a sort of a sketch of the history of the theory, but I will keep coming back to the overall theme, these of the European US interactions. The story was going to be a sort of reasonably straightforward story of a shift from lots of European work, not influenced very much by American work, and then as the century progressed, there's much more American work appearing in this area. But my realization was that there's an American influence much earlier than I had originally realized, so that's something I'll include here. Okay, so I thought I should begin with some definitions. I suspect that all of this is okay for this audience. I'm sort of assuming a very basic knowledge of abstract algebra, but I thought I'd throw in some definitions to begin with. So semigroup, as I'm sure most people here know, is a non-empty set with an associative binary operation. If it has an identity element, then it's a monoid. There's a special class of monoids that we might occasionally be interested in. They're known as groups. And so an unflattering way of looking at a semigroup is that it's a defective group. It's got a couple of properties missing. Or alternatively, you take a ring and you just look at the multiplicative part. You just dropped an entire operation. Again, you might, in a very unflattering way, look at semigroups as being defective rings. And this is two of the places where the theory came from. And it's interesting to trace where you have these almost trivial-looking problems coming from groups, from rings, and then sort of independent theory begins to emerge much later on. One of the major motivations, though, for studying semigroups is that the collection of all self-mappings of a set is a semigroup. Well, in fact, a monoid. So if you go beyond just the bijective maps, you need a structure to describe them, and that's where semigroups come in. Okay, so that's the definition. So an overview then of the talk is that, well, I'll start with just a rough outline of the development of the theory. I'm not going to go into enormous detail here. And so then I'll go back to the beginning of the 20th century with the postulate analysis that was very popular amongst a small group of American mathematicians mainly in the first decade of the 20th century. That has a relevance to this story, certainly in terms of definitions, and not so much in terms of theory, but that there's something to be said there. I'll then comment on the early theory, where that came from, leading to the first structure theorems for semigroups. So initially it's structure theorems that are analogues of things for groups and rings, and then it becomes structure theorems that have no analogues for groups and rings. So this is where I sort of see the beginning of this independent theory emerging in the 1940s. Because of certain pieces of work in the early 1940s, the theory expanded then quite rapidly, and I'm not going to say too much about the theory after this point, but I certainly want to comment on the expansion, the consolidation of the theory in the 1940s and 50s. And then I'll make some general conclusions about the European and US interactions. And then if I have time, I have just an extra bit at the end, which I hope I'm not going to be subverting the theme of the meeting too much, but I think there's a slightly different question that can be addressed, so I'll come to that at the end if I have a chance. Okay, so just to give a very simple sketch of the development of semigroup theory, I should say I'm talking the algebraic theory. There is a parallel topological theory which has a sort of very different development, and the two interact occasionally, but this is very much algebraic work. So at the beginning of the 20th century, you have some early hints of definitions, certain ideas emerging in the postulate work that I just mentioned, and there is both a French and an American connection here, which I will come to shortly. Then there's a sort of a lull for about 20 years, and certain problems related to groups begin to give rise to semigroup theoretic ideas in the 1920s, mainly in the work of a Russian mathematician based in Ukraine. And I should perhaps comment at this point that the theme is European versus American mathematics, and I do count Russia as part of Europe, and Britain for that matter. So there's a lot of work in the USSR at this time, mainly coming from the point of view of looking at self-mappings of a set, looking at the structure there. As we move into the 1930s, people are beginning to think, well, we can also approach this from a ring theoretic direction. There are results about factorization in rings that seem to only use the multiplicative part of the ring. So can we just develop a purely multiplicative theory? So this is the sort of problem that arises here. Similarly, there are questions about embedding rings in skew fields that are adapted to questions about embedding semigroups in groups. And then there's some more postulate work that pops up at this time, coming from a group theoretic angle. And then we get to the 1940s, the first structure theorems, as I said, the ones that were analogues for groups and rings, and then the more independent things. And then you begin to see a great spread in where the theory is being carried out. So down to here, we've got France, USA, USSR, UK, and that's about it, really. But after this point, you start to see Czechoslovakia, you see German work, you see it's sort of spreading across Europe. And the theory is really being consolidated at this point. What had come before this point were isolated results, but here people are starting to put together a systematic picture of what this theory should look like. So they're looking at homomorphisms and equivalence relations on semigroups and ideals and sub-semigroups and building up the sort of general algebraic machinery that you should have attached to this sort of theory. So then the 1950s, a bit more consolidation, work beginning to appear in Japan, for example, via an American influence. And then right down here at the end, something that I might come to later, is that a lack of communication between East and West had led to two parallel theories, mainly American and Soviet work. They were arriving quite often at the same place, but by different routes, and it was quite interesting to look at the different approaches they took to the theory. Okay, so that's just to give you a sort of a shape, the idea of the shape of the theory. So I'll go back to the beginning now, and say a little bit about this postulate analysis. So this isn't really semigroup theoretic work in a way, but it's relevant to some of the things I want to say. This is really group theoretic or group axiomatic. But it comes from this source, essentially, from David Hilbert's axiomatization of geometry. So, of course, as you know, at the end of the 19th century, there's quite a significant German influence on American mathematics. A lot of US mathematicians had been to Germany to take PhDs, so we saw that with Virgil Snyder. And And so there's a great awareness in the US of German work, again, as we were seeing. And certainly this book on the axiomatization of geometry was picked up in particular by E.H. Moore at the University of Chicago. He organized a seminar to study this book, to study the axiomatization of geometry. And then this idea of axiomatization, of studying postulate systems for their own sake, spread to other parts of mathematics and to algebra in particular. And there's quite a group of American mathematicians who became obsessed by this. So this is E.V. Huntington, E.H. Moore, Oswald Veblen, Leonard Dickson. And here's just a page from one of Huntington's papers on this subject. So Huntington was one of the main authors in this area. He was really experimenting with different sets of postulates for different objects. Groups got a lot of attention, so this is a paper about definitions for abelian groups. And the big questions were, when are the postulates independent? When can we have a minimal set of postulates? What do we mean by a minimal set of postulates? And so on. And this, I think, attitudes to this sort of mathematics became quite dismissive, but I've been working on this quite recently and really going into detail in what these people were doing. And I think there's a real sense that they, in the example of a group, for example, they really thought that by pulling the definition apart in this way, they were gaining a great understanding of what a group was. So I think there's something to be said for this work. Okay, so into this mix, we introduce de Segier's book on abstract groups. I put this picture here because I have failed to find out much information about de Segier. So if anybody could point me in the right direction, I'd be very happy. He has a little bit in Poggendorf, but that's about all I know. So if anybody has any information, I'd be very happy. So this is one of the first texts to deal with groups in the abstract setting, in a finite case. And it was reviewed by Leonard Dickson for Bulletin of the AMS. So this review presumably contributed to some of the figures that we've just seen. And Dickson was quite interested, given his postulational interests, in a definition that de Segier had given. So de Segier had this very elaborate definition where we have set G with a generating set S with respect to some binary operation. And he says this is a semigroup if we have the associative law and we have these two conditions relating to the solvability of equations. But the phrasing is not entirely straightforward because A is from the generating set, B is any element, and so it's a little bit complicated. And you'll see, of course, it's not the modern definition of a semigroup. And one of the things that de Segier did with this definition is he deduced that you have the cancellation law, that follows from his definition, he claimed. And so, actually, just to look at this in modern terms, de Segier's definition of a semigroup is what we would now call a finite cancellative semigroup, and it's an easy exercise to show that, in fact, that's a group. And actually, the point of de Segier's definition was that he wanted to propose a structure that was a group when finite, but something else when infinite. And he came up with a very elaborate construction involving the homomorphic relation between two groups and certain between two groups and certain sub-semigroups that were groups when finite and not otherwise, and it's all very complicated. Okay, but Dickson objected to some of de Segier's reasoning here. There's some complications with the idea that he had this generating set, where exactly were the elements coming from in the arguments that de Segier was given. So Dickson proposed that, in fact, let's just throw away de Segier's definition and let's give this definition for a semigroup. He introduced a hyphen along the way, perhaps to sort of emphasize the connection with groups. But he stuck closure in as a property, he has associativity, and then he has the two cancellation conditions. And this is the notion of semigroup that you still see cropping up much later on. So Paul Dubray, for example, when he wrote about semigroups, he used this definition of semigroup and used the word demigroup for the thing satisfying just those two conditions. Okay, so that's just sort of essentially just a few comments on where the name semigroup comes from, but there is some relevance to what I'm about to say. So that's not really a semigroup theory. So to find the theory beginning to emerge properly, as I said, we have to look to Soviet Ukraine and to this man, Anton Sushkevich. He's someone whose work I've been interested in for quite some time. I find it endlessly fascinating, although I have to acknowledge that his influence as a figure, he's not a major figure at all. He's very lowly figure in sort of the story of mathematics in the 20th century, but I mean there is some value in looking at the minor figures. And he did lots of work in algebra. He worked in history of mathematics. He was interested in the development of algebra in Russia, for example. He did a lot of pedagogical work. I think there are some interesting things to say about his textbooks on algebra. There's something I'm starting to work on. But anyway, in 1917 or thereabouts, he wrote this thesis, the theory of operations as the general theory of groups. And it has things to say about semigroups. It has things to say about what we would now term quasi-groups, and there are other generalizations of groups in there. And he continued to work on this material for about 20 years and a little bit afterwards. But certainly 20 years after the dissertation, he wrote a monograph, Theory of Generalized Groups, 1937, which has a very much refined version of the ideas from here. And his motivation, for the most part, was what he referred to as generalized substitutions. He was very often working in the finite case, so he wrote things down like this. So it's the very traditional two-row notation that you see for permutations, that he was adapting to the case of not necessarily invertible transformations. So that was the motivation, and he saw his work as being embedded very much in the kind of tradition set up in Russia, subsequently the Soviet Union, by this man, Otto Schmidt, group theorist, Soviet politician, Arctic explorer, who wrote a very influential book in 1916, Abstract Theory of Groups, in Russian. And this seems to have been the thing that kick-started an interest, a really deep interest in abstract groups in Russia. And so Sushkevich, although he wasn't actually dealing with groups, saw his work as being embedded very much in the sort of literature that Schmidt had initiated. There's somebody else whose picture I could also have put here, and that's a man called Dmitry Gravia, who ran an algebra seminar for many years in Kiev, and I think there may be some influence from him as well, but I can't say very much about that at the moment. That needs a bit more work. Okay, so this is very obviously a source of motivation for Sushkevich, this idea of non-invertible transformations. But the sudden revelation that I mentioned was I think there may also be an influence from the postulate analysts. So I'd read this comments like this from Sushkevich before, sort of moving to other operations with properties substantially different from those of the particular operation of ordinary groups. And I hadn't really thought anything about this before. But suddenly I realized I think there is an influence from the postulate analysts here. Certainly when it comes to giving a definition for an ordinary group, Sushkevich often appeals to Frobenius. He studied in Berlin in the first decade of the 20th century. Frobenius was one of the people whose lectures he attended. And so he always cites Frobenius for the definition of a group, usually a finite group. But then I started to realize that here and there he also cites Huntington and Moore and Dixon, and not in a big way, but it's quite subtle. And so I think there's some influence there, and suddenly it's obvious to me that this is there, and I don't know why I haven't seen it before. And I realized also that I've been sitting on material for this for several years without realizing I had it. So that gives me an excuse to show this photo. Sushkevich spent most of his life in what is now Kharkiv in eastern Ukraine. This is Kharkiv National University, which Sushkevich would have known in Russian as Kharkov State University. This statue of Lenin is no longer there. This is a picture I took on a trip there a few years ago, but this was toppled about a year or two ago by pro-Western demonstrators. So there's sort of some historical interest in this photo. But There's a room in the university here where they keep an archive of various materials relating to former members of staff. And there's a bag of papers written by Šuškevič, which are his notes on various papers that he's read. They are meticulously dated, so we know when he read them. And the work of the postulant analysts is among this material. And as I said, I've had copies of this for years and not realized what I had. So suddenly I think that this influence is there and I need to do something else with it. So as I said, I planned to give a talk where I spoke about a gradually increasing American influence on this semigroup theoretic work. But I think it's there much earlier in a much more subtle way than I had previously realized. Okay, so there's this mixture of influences on Šuškevič then. So coming from the generalized substitutions angle, we have results like this one. Every semigroup can be embedded in a semigroup of transformations. This is published in German, so you have a German spelling of his name there. And so this is a semigroup version of the Cayley theorem for groups. But then you have a much more elaborate side to his work. I'm not going to worry too much about the details here. I've just put this up for completeness. In a slightly later paper, which turned out to be possibly his only influential paper in the development of the theory, really. He's looking at finite semigroups. He picks out minimal left ideals. He shows that these are right cancellative. They satisfy the right cancellation law. And that's another piece of circumstantial evidence that there's some postulational influence here, because usually you get both sides of the cancellation law together. And it only seems to be it's mainly the postulant analysts who split them up into left cancellation and right cancellation. So the fact that Šuškevič has two separate cancellation laws makes me wonder if there's something going on here as well. And anyway, he showed that every one of these is a union of isomorphic copies of a group, and then does a similar thing with the right ideals, minimal right ideals, and then he picks out this thing that he calls the kernel of a finite semigroup, which looks like this, so it's a union of groups. And he draws nice pictures, nice schematic representation of this thing. And this kernel K is a minimal ideal of a semigroup, and so he shows that every semigroup has one of these minimal ideals, and it's a union of groups. So it's the fact that it's a union of groups which is the relevant detail here. So again, just for completeness, this is Šuškevič's statement of his results. So you take a finite semigroup, and he says every finite semigroup has a minimal ideal K determined by certain conditions, mainly relating to how you put these groups together in this union. So if we take the union and you're inside one group, you know how to multiply the elements, but if you want to take elements from different groups, you have to know how to combine them. So that's what this is about. And we can also build a kernel sort of without reference to a containing semigroup, and so this gives us a structure theorem for finite simple semigroups. So semigroups having no non-trivial proper ideals. So this is an early structure theorem. It's not necessarily in a very usable form, but people did come back to this a little bit later. And so I think this is a structure that was mimicked by some later authors in slightly different contexts. And it's so therefore possibly the only thing that had any real impact in the development of the theory. But as I said, I think at a sort of educational level, Šuškevič has more importance. His textbooks ran to several editions in both Russian and Ukrainian, so I think there's something to be said there, which I'm investigating. So mostly this seems to have sort of sprung from Šuškevič's work on generalized substitutions, but he includes a passing reference to SHM Wedderburn, who of course had done some work on the structure of simple algebras, simple rings. And I just thought I'd put Wedderburn in here because really he was Scottish, but he worked in Princeton for a long time, so I count this as possibly an American influence here on the theory. but it's only a passing reference, sort of recognition that there is some sort of common element between what Sushkevich was doing and what Wedderburn was doing. But it's only a little bit later that that connection was made more explicitly. So I move now to the more general structure theorems. And an influence here is from A.A. Albert's Structure of Algebras in the AMS Colloquium Publications series. This was read by this man, David Rees, who, while still an undergraduate, wrote this paper on the structure of simple semigroups, or completely simple semigroups, which is a term I'll define in a moment. And whereas Sushkevich had been coming from a very group theoretic direction, this is now coming from the Albert Wedderburn type tradition of rings and algebras. So we're now essentially looking at the ideas that you have in relation to rings, but dropping the addition and seeing what happens in the multiplicative context. So again, this is just for completeness that I've put some mathematics up here. So for Sushkevich, the semigroups were finite, so that gave him something to work with. When you move to the infinite case, there's not quite enough structure to work with, so he had to define this notion of completely simple semigroup, which is a semigroup with primitive idempotent elements, which is a concept adapted from ring theory. You can also look at this in terms of descending chain conditions, which some people prefer. But certainly he defined this idea of a completely simple semigroup. And unlike Sushkevich, who, as I said, was thinking groups, Sushkevich's semigroups couldn't have zeros, but Ries's ones could, because he was coming from a ring theoretic direction, so it's sort of more natural that they could have a zero. So you need a slightly different definition where there's a zero in play, but I've left that off the slide. He then defines this thing, which we now term a Ries matrix semigroup, which is essentially a product of a group with two sets, with multiplication that works like this, with reference to a matrix, which is indexed by these two sets. And if you squint a little, you can see that actually these triples consist of two elements from the set with a group in the middle, a group element in the middle. And so really this is just a union of groups. So it's a similar idea to Sushkevich. And Ries proved that any one of these is completely simple, and any completely simple semigroup is isomorphic to something constructed like this, which happens to be a union of groups. And it's difficult to tell quite where, at what point Ries became aware of Sushkevich's work, but again, there's a footnote, which you could probably just see here, with a single reference to Sushkevich, but I think this is probably inserted after the fact, that he developed these ideas and then discovered the connection. Okay, and I should just maybe comment that this is a semigroup version of the Wedderburn-Artin theorem for rings, which gives you a characterization of simple rings as matrix rings. Okay, so we get to the beginning of the 1940s then. Sushkevich has had a little bit of influence on one or two people have sort of played with semigroups a little bit, but Ries's paper seems to be the thing that really kicked things off. So that the theory began to expand quite rapidly at this point, prompted by Ries in some cases, but not in others. But this is where we begin to get a really significant American input into the theory. And just at an international level, this theory is becoming more popular. So we certainly have Paul Debré, for example. He wasn't influenced by Ries, as far as I can tell. He was just investigating equivalence relations on various algebraic objects, semigroups being one of them. He was looking at group homomorphic images of these things as well. You have Stefan Schwarz, who was one of the few people to build directly on Sushkevich's work. You have Hans-Jürgen Hörnke in East Germany, links with Brandt groupoids. Gordon Preston in Oxford, looking at semigroups of partial transformations. You begin to get Japanese contributions, Hungarian ones, and so on. So that the theory is spreading. And I said there's a major American influence at this point, and I haven't put it on this slide, but there's one name to mention in particular, and that's this man, Alfred Clifford, who is a student of E.T. Bell and Morgan Ward at Caltech. And he had been doing some semigroup theoretic work in the 1930s. There's a paper here that he published in 1933, a system arising from a weakened set of group postulates, where he described a certain class of semigroups which turned out to be a union of groups. And then he picked up on this idea again in a paper of 1941, where he appears to have developed some of the same ideas as Riesz independently, and he sort of put them all together into this paper. And again, he describes semigroups that are unions of groups. So this seems to be a kind of a big thing that appears in the semigroup literature, and it pops up independently in various places. So we've seen it with Šuškevič's work, but his characterization of the semigroups where this is relevant wasn't in a particularly usable form. It seems to be the form that Clifford gave, or that Riesz gave as well. It's a slightly different version, that seemed to be usable and seemed to inspire people to go further. So in Clifford's work, we see these ideas coming from postulational questions. He ends up with, he looks at the finite case as unions of disjoint isomorphic groups, so like Šuškevič. He moves to the infinite case and looks at, again, unions of disjoint isomorphic groups, like Riesz. And then he moves in a much more general direction. And this is where one of the places where I think you can point to the beginnings of an independent theory of semigroups, because now we're not insisting the groups have to be isomorphic. There's a lot more theory needed as to how to put these things together. And so there's quite an elaborate theorem that Clifford proves about these things that I think is the sort of real starting point for this independent theory. And Clifford worked on other things. I've already mentioned the idea of factorization in semigroups. That's something that was in some work of his of the 1930s. And he began looking at representations of semigroups, so adapting group representation theory to a semigroup theoretic context, which is still an ongoing area of investigation. So Clifford became very well established in the United States after the war. He moved to Tulane University in New Orleans, and he began to publish lots of papers on semigroups. He supervised students. He was the co-author of the first textbook on the algebraic theory of semigroups. And also in Tulane, we have Alexander Wallace, who is Clifford's counterpart, but on the topological side of the theory that I haven't been talking about. So between them, they made Tulane a center for this kind of work. Certainly semigroup theoretic work was going on in other places, but this became a major center. And I think this is where you begin to see the major American influence on the theory now. This is sort of the United States is where the bulk of the work on this theory is going on by this stage, so 1950 and afterwards. And so that was the story that I'd originally intended to tell. So this very simple interpretation that the focus of semigroup theoretic work was very much in Europe at the beginning of the 20th century. By mid-century, it's shifted to the USA. And then I started to think about the word interaction, the word that I've been given. And it struck me that in many cases there isn't a lot of interaction as such. Somebody writes a paper and publishes it, and somebody else reads that and does some work based on it. So they're not really interacting in any real way, at least not early on. It's only when you've got the big centers of semigroup theoretic work, so Tulane, I mean, Paris also was with the work of Paul Degré. And so so as I say, I don't think there was a lot of interaction earlier on, but certainly that comes later when the theory is much more firmly established. And I just want to make a distinction between interaction and influence. So I think influence is a much broader thing, and certainly you see that. And I keep talking about a possible postulational influence on Šuškevič. So it's a more subtle thing. It's reading publications and possibly doing something based on them, whereas interaction, of course, is a more active thing. So yeah, so there's sort of a very clear simplistic interpretation of the development of this theory that the center of gravity, if you like, shifts from Europe to the United States, but the American influence is there a little bit earlier, but I still have to look into that a bit more. Okay, so those were my conclusions, and I said that I had a sort of addendum to the talk, which I hope doesn't go too far away from the theme that I was given. But I started to think about this interaction versus influence distinction, and realized that there's possibly another dimension to consider here. So if you know anything about this theory, what you may have realized from my list of contributors earlier on, when I was talking about Stefan Schwarz in Czechoslovakia and Hans-Jürgen Hörnke and the GDR and so on, I didn't say anything about later Soviet contributions. And certainly later on, there's this great East-West divide in the development of the theory, as I was saying. Now, the problem with the Soviet contributions is that Szyszkewicz's work was largely overlooked. Strangely, he seems to have had more influence in the West than he did in the USSR. Well, I say strangely, it's perhaps not strange, because his major work in this direction was published in German journals, so maybe that's where that comes from. And it wasn't until the 1950s when his student, Gluskin, began to reintegrate Szyszkewicz's work into what by that time had become a sort of a reborn Soviet semigroup theory, mostly in the work of E.S. Yapin in Leningrad, who was somebody who seemed to be very well versed in the contributions of Rees and Clifford, and he was building on those things. And he was a group theorist by training, and so he came at the theory from, with a group theoretic mindset, and he looked at things like kernels of homomorphisms of semigroups, and tried to come up with a sensible notion of a normal subsemigroup and make it behave in the same sort of way that a normal subgroup works, and so on. And there's certainly a slightly different influence, a slightly different emphasis in Soviet semigroup theory. And there's a lot more emphasis placed on various classes of semigroups of transformations, arbitrary transformations, 1-1 transformations, 1-1 partial transformations, and so on, and related embedding problems, so taking an abstract semigroup, embedding it in various different types of semigroups of transformations or semigroups of matrices. As I've said, there's the idea of replicating group theoretic notions in a semigroup theoretic context, like normal subgroups to normal subsemigroups. And then there are lots of other things. There are sort of lattice properties of semigroups, where you look at lattices of subsemigroups and try to deduce something about the semigroup from that. And sometimes there were interactions between the Soviet work and the rest of the world, sometimes there were not. And so I've already mentioned the duplication of results. And so the communications difficulties were slightly different on each side of the Iron Curtain. On the eastern side, the difficulties were largely political ones, censorship and so on. In the West, it was much more a matter of linguistic problems, because people in the West, on the whole, don't read Russian so well. There's a particularly noteworthy example, which is something I've been interested in, the notion of an inverse semigroup, which is a nice thing that lets you describe partial symmetries of objects. This pops up in the work of Victor Wagner in Saratov and Gordon Preston in Oxford. And so more generally, you also see this in, sort of going back to the US context, you see this in duplication of US and Soviet work. At the same time, after, say, about 1950, when the theory was really well established, you have regular interactions between US and Western European mathematicians, but then there's on the Eastern European side, that's not working quite so well. There's a lot of duplication here. So I sort of thought that maybe this theme of US-European interaction maybe needs this extra dimension, that there are two Europes in a way when we look at this. Okay, so what happened here? Well, ignorance of the work of the other side left certain topics largely untouched. I've just been working on a translation of a piece of work by Wagner, who we saw a moment ago, which just isn't known in the West at all, and I think it's quite an interesting piece of work. And there's a sense of competition, people trying to get to results. They're working in a similar area, they're trying to get there first. And the reason that I sort of go on about semigroup theory so much is that I think it's a theory that really serves very well to illustrate this development. Certainly this east-west divide, but also I think it also provides a nice example of the overall theme, the US-European interactions. Probably because it's a theory that developed over the course of the 20th century, particularly in the second half of the century, so that relates more to this sort of theme. But certainly it's not simply a question of interaction, there's also this question of a lack of interaction, which I would argue also had its effect on things. Okay, so just some final thoughts, given where I am. I've mentioned Paul Dubray a couple of times and said that there was certainly a great deal of semigroup theoretic work going on in Paris. And this was centered on Dubray's seminar in algebra and number theory. And if you look through the seminar lists, you find that there's a great deal of participation from US speakers. So this is very much a sort of focal point of this US-European interaction, at least as far as algebra and number theory are concerned, semigroup theory in particular. And you also find some Eastern European speakers, not Soviet speakers so much, but there are Czech speakers, there are Hungarian speakers at these events. And so it strikes me that this is probably a very good meeting point, at least for the ideas, if not for the people, particularly when you also find reports of Soviet work being presented at these meetings. Translations of Russian work are presented by people here. So it's brought to a wider readership, even if the Soviet authors themselves couldn't actually come to these seminars. So it seems to be this sort of real melting pot of ideas in this seminar. And I don't know if anybody has ever actually done any detailed work on the proceedings of this seminar. And it struck me that might be an interesting thing to do. On the other hand, if it has been done, then I guess somebody here will probably know about it. But yeah, so that's just my final thought. So I think I should stop there.
Thank you very much for your talk. So I just have first a comment. It's about Jean-Armand de Séguier. It was the Jesuit abbot, actually. And so, I mean, at the time, I mean, you have many Jesuit abbots who were doing researches in mathematics in France, I mean, still at the time. He was very close to Camille Jordan, and actually very influenced. Jordan was very influential in his works. He was also a teacher of mathematics in a Catholic high school in Versailles. Right. So he was, I mean, publishing mathematics, but he also published a lot in the Jesuit journal Études. And actually it's quite interesting because you can see that his fascination for abstraction, and I mean, his book is about abstract groups, is connected to a fascination for transcendence and in general in connection with religion issues. But he is also a witness of a broader French tradition of abstraction, actually, which is completely disconnected from the influence of Hilbert's approach to axiomatic geometry, but was identified as such at the time, especially in Germany, but also in the US. And you have several actors who are referring to the French abstraction, which is quite funny when you think about it, retrospectively, but actually it's the case. And of course, a major player in this tradition is Maurice Fréchet. And actually, Maurice Fréchet's work is very close to the one of Jean-Armand de Séguier. So it's a kind of approach to abstraction which is very different from the one of Hilbert and also from the one of the postulationist school in the USA. So that was just a comment about de Séguier. And so my question was about Paul Dubray. I was wondering if you know his paper on the history of semigroups theory in France.
I do, yes. I can't remember.
Actually, it was published in 1981 in the proceedings of this seminar, the Séminaire d'Histoire des Mathématiques,
Oh, yes.
which used to have his own proceedings. That was before the creation of the Revue d'Histoire des Mathématiques, and now also we have the videos recording talks. So he gave a talk in this seminar about this history, and what is interesting is that he is describing quite precisely the way he got interested in the semigroup theory. So of course he knew about the works of De Seguier, but that's not actually the point. So what he says is that, I mean, as many French students from the 1920s, he got a Rockefeller grant, went to Germany, especially studied especially with Artin and Noether, and then was very much influenced by the German modern algebra, and it says that in the second edition of van der Waerden in 1937, he found that there was a new footnote referring, and this was about commutative rings, referring to the work of Massev, and in the paper of Massev, he found a reference to the work of Schuskevich. And so eventually got involved with semigroups this way. So in that case, I mean, there is a quite interesting form of interaction that comes from a kind of acculturation. I mean, interaction really between people, especially the people that Dubreuil met in Göttingen and Hamburg and so on, and the way he got trained in the modern algebra, which eventually, with the intertextual relationships, got it involved with semigroups, but through other theories. And so about Dubreuil, as you mentioned, his seminars of possible other places of interaction, I wondered if you knew that there's a lot of archives at Jussieu, of his professional archives, actually. I mean, about his teaching and also lectures, conferences, drafts of papers, and these kind of things. And I don't think that no one ever looked at them.
Okay, no, I didn't know about that. I thought this would be a good thing to look at, but I haven't actually looked at it as yet. But that would be a very good starting place, I think.
D'autres questions? Okay, so maybe I should ask you a few questions. I was wondering, you mentioned different theorems that occurred that were designed for semigroups in the 1940s, and you mentioned that some of them use lattices, well, of course, to do the structure theorem, some structure theorem of the semigroups. Are these theorems possible to obtain without lattices, or are lattices precisely necessary to have these theorems?
Well, the one that the line of investigation that comes to mind relates to what were referred to as simply as lattice properties of semigroups, so properties of the lattice of subsemigroups. So, yeah, I mean, the lattice is a very important part of what's being done, I think there was sort of a notion of lattice isomorphism. So if the lattices of subsemigroups of two semigroups were isomorphic, then the semigroups themselves were said to be lattice isomorphic. And there was some significance to looking into this problem, and I can't quite remember what the point of it was. But yeah, the lattices are key to what was being done there.
Okay, and do these people that you talked about, do they recognize themselves of being theoreticians of semigroups, or do they participate in a more generalizations of groups and trying just to work on this generalization, or is it a specific theory of semigroups and nothing else? Or do they work on loops? And
I think everybody I've mentioned was very specifically interested in semigroups. I can't think of... I did mention Brandt groupoids at one point without really explaining it. So systems with partial operations. So very occasionally that comes in. It certainly comes in here as well. But yeah, all of these people were very much semigroup focused. Wagner, wherever he is, I can't find him anyway. So I had Wagner and Preston down here. Wagner was also interested in a system with a ternary operation, which came from certain sort of an axiomatization of certain systems in differential geometry, coordinate atlases and so on, which is linked very closely to the semigroup theoretic work that he was doing. And particularly this thing with the ternary operation is the thing that I've been translating, because it just isn't known in the West at all. And it's a really nice theory. So Wagner was probably a rare example of somebody doing things beyond semigroups, possibly because he wasn't an algebraist to begin with. He was a differential geometer who had found that algebra was useful for what he was doing. So it was a much wider interest in algebra than necessarily just semigroups. But yeah, on the whole, they're mainly focused on semigroups.
So thank you very much again.